Hi guys, and welcome to class again. Today, this is what we do in EDU-SOLUTION, always ready to provide answers to every of your questions. So if you are just meeting us for the first time, just go ahead, follow us in every of our social media. You will be the first to receive content as soon as it drops. So we are having a question in physics today. The question says, 5 conductors meet at a junction. The current in the 4 of them are 3 ampere towards junction, 5 ampere away from the junction, 2 ampere away from junction, and 4 ampere towards junction. What is the magnitude and direction of the current in the 5th conductor? You will remember that Kirchhoff's current rule says that the sum of current flowing into a junction is equal to the sum of current that is flowing out from the junction or flowing away from the junction. Now, we are having a question. What we simply do is we are going to identify which of them are flowing towards the junction. It's even basic enough because it has been specified in the question. This is a JAMB question, a UTME question. So we're having that 5 conductors meet at a junction. So now let's pick it from here. The current in 4 of them are 3 ampere. This first one, 3 ampere, is flowing towards the junction. If I am going to represent it with a diagram, let's assume this is the junction. I have like this one. Okay, I have just 5 because there are 5 conductors. So this is the junction. Okay, the node junction. I have the question says let's pick it up. So the current in 4 of them are 3 ampere. The 3 ampere is flowing towards the junction. So this is the junction. Let me take this as 3 ampere flowing towards the junction, and then again 5 ampere away from the junction. Since it's away, the arrowhead will point outside. 5 ampere away from the junction, and then 4 ampere towards junction. So let me assume I can put it here. It does not mean I can have 4 ampere is flowing towards the junction, and then again the last one was 2 ampere away from the junction. I think I skipped that. So 2 ampere away from the junction. Let me use this is leaving. We have 2 ampere away from the junction, and the last one. So that's what we don't know. So if I go over it again, the current in the question says 5 conductors meet at a junction. This is the junction. The current in 4 of them are 3 ampere. They want to describe the 4 of them. The first one is 3 ampere moving towards the junction. That's what we have here. You can see the arrowhead is moving towards the junction. 5 ampere. The 5 ampere is flowing away from the junction. And then we have 2 ampere also flowing away from the junction. That's why it's pointing outside. Finally, 4 ampere is moving towards the junction. The question is, what is the magnitude? What is the value of the last one, and also what direction will that last one be? Is it flowing towards the junction or away from the junction? So this is a Kirchhoff's rule. Okay, which says, I think I've stated that before, the sum of the current flowing into a junction is equal to the sum of the current flowing out of the junction. Just to quickly add that Kirchhoff's first law or current law, it deals with the principle of conservation of charge. You may be asked that in exam. Why the Kirchhoff's voltage law deals with the conservation of what? Energy. That of the current deals with what? Charge. And that of the voltage deals with what? Energy. Back to our question. So the law says that the sum of current flowing into a junction, let's call this I in, is equal to the sum of current that is flowing away from the junction. So we have I here represents the current, and this sigma represents the sum, and then we have out. So we can have the current flowing in is equal to the current flowing out. So if we want to do it, we have the one flowing in, we have 5 of them. Okay, so we don't know whether this last one, whether it's flowing in or flowing out. That's what we're looking for. So what we're going to do is, let's find out the one that is flowing in. If you check it, this first one, 3 ampere is flowing in, 4 ampere is flowing in. So we are going to add them together. We have the current that are in is equal to, we have 3 ampere plus this again. Okay, this again is also flowing in 4. So we have 4 ampere. So that if you add them together, it's going to give you what? 7 ampere. So this is the sum of the current that is flowing in. Meanwhile, this is in. So this is the sum of the current that is flowing into the junction, which is 4 plus 3. So let's find out the one that is flowing out. So we have the one flowing out is this 5 ampere, or 5 ampere plus this is also flowing out, which is 2 ampere. So if you add them together, it's going to give you what? 7 ampere. So they ask us to find the fifth one. What is going to be the fifth one? What is going to be the value? And what direction is it flowing in or flowing out? You don't need to stress yourself. We have gotten our answer here. Because according to Kirchhoff's current law, it says that the sum of current flowing into a junction is equal to the sum of current flowing out of the junction. If you check our in now, current in is 7 ampere. Current out is 7 ampere. So that means the equation here is already balanced. So we don't need to stress ourselves. This is just a trick. The equation is already balanced. You can see that 7 is flowing in, 7 is flowing out. So that means the fifth one, the value of the fifth one is what? 0. They just want to test you to know whether you are guessing your answer or you actually know what you are doing. So from this our solving, it has satisfied Kirchhoff's first law. So that means our answer, the last one that we're looking for, the fifth one is what? 0. So that means the last current, we don't know whether it's going in or out, whether we put it in or put it out, same thing. So we're having the last one is what? Let me call it the fifth current is equal to what? 0 ampere. So that's our answer. See you in our next class. Have a nice day.